So take a look at how do we move terms over on either side. And now we're going to look at another small section that's on rational coefficients. Okay, so rational coefficients, also known as fractions, okay, can be used as well. So we might have a rational coefficient. We've taken a little bit of a look at that as well, but we're going to take a look at how do we get rid of them when there are multiple terms, or what do we need to do when we have multiple terms. Okay. So when a fraction is part of the equation, okay, to solve for a variable, okay, it needs to be simplified by multiplying by the denominator. So we can actually remove a fraction by multiplying by the denominator. Okay? By multiplying it by the denominator, we get rid of the fraction. It's exactly what we did when we did opposite operations. That denominator is dividing, and so the opposite thing is to multiply. That's how we get rid of it. But we have to multiply. If we're multiplying one term, we have to multiply all the terms by the same amount. So this first one here, we have u divided by 3. We want to get rid of that 3, which is in the denominator. So we need to multiply both sides, or every term, by 3. So we're going to multiply this term by 3, and we're going to multiply this term by 3, okay, on both sides. These ones here is going to cancel out. It's because 3 divided by 3 is 1, so it becomes 1u. Okay, it becomes 1u. And so over here, and again, this is a little bit of review as to what we've done in the past. Okay, so on this side here, we're going to get u all by itself, and then we're going to have 4 times 3, which is 12. Okay, so our u is going to be 12. 12 divided by 3 is 4. That, in fact, does work, and so that is a good thing. Now, when we are when multiplying to simplify the equation, as I've mentioned and as I've tried to stress over and over again, each term needs to be multiplied by the same value. Okay, so it's not just each side, it's each term has to be multiplied by the same value. So here we have another equation here where we have 3 terms. We have this fraction, the constant, and then this other term on the other side of the equal sign. We have a fraction, so we want to get rid of that fraction. Okay, it's important that we get rid of the fraction before we can solve, because otherwise we just cannot solve. So that means that to get rid of that fraction, we need to multiply it by 2, but we also have to multiply this value by 2, and we have to multiply this value by 2. We have to multiply every single term by 2. This one here, when we multiply by 2, it cancels out because we have the same denominator, okay, which is really handy. So all we're going to be left with is x all by itself. Sorry, just x all by itself. The next one, the 3, we multiply that by 2, that becomes 6. And on the other side, we have 2x. When we multiply that by 2, it becomes 4x. Okay, so when we multiply a term by 2, it becomes 4x. Now we don't have any more fractions. We can go through the process of moving terms onto to different sides. So if we want to get the 6 all by itself here, we're going to get rid of x. So we subtract x from both sides. And when we do that, it eliminates it on the left-hand side. We're going to be left with just 6 on the left-hand side. And on the right-hand side, we have 4x minus x, which just gives us 3x. And then, well, we have only the one term that has x in it, so we can now solve for x by isolating it. And remember, there's our little code word or keyword is to isolate. We do that by dividing by 3 on this side, dividing this side by 3. And that's going to give us, so 6 divided by 3 is 2. And 3 divided by 3 is just 1, right? So then we have x left over there. So x has to be 2. So this is 2 divided by 2 is 1, plus 3 is 4. 2 times 2 is 4, so 4 is equal to 4. So that, in fact, works out really nice. All right, let's try a couple more here. Then we're going to go through where we need to multiply by our denominator. So in the first one here, let's get a different color here. We have a denominator of 3. Now, there's only one denominator. We'll get into multiple denominators later on. We have one denominator, it's just 3. So we're going to multiply every side by 3. Or sorry, every term by 3. Okay, so we're going to start by doing multiplying every term by 3. The first term here, okay, the 2k divided by 3, when we multiply by 3, 3 divided by 3, and we can think of it this way, 3 divided by 3 is just 1, so we're multiplying this whole thing by 1, so it's going to stay exactly as 2k. We multiply the 3 by 3 becomes 9, and we multiply 5x by 3, this becomes 15x. Okay, so it becomes 15x. Now, again, we go through that same process of moving all of our variables onto one side. So we're going to subtract 2k from this side, and we're going to subtract 2k from this side. And when we do that, this side's going to be just the constant, and the other side we're going to have 15 minus 2, which is 13k. We're going to have 13k. Now, our last step then is to isolate k, get it all by itself. So we need to divide this by 13, and we divide this by 13. Okay, when we do that, the 13 is going to cancel out. And so what we're going to have here as our final answer, okay, is we're going to have negative 9 over 13 is equal to k. And that's our final answer. Let's leave it right as a fraction. We could, divide them as well. Okay, so if we divide negative 9 divided by 13, we're going to get negative 0.69. Okay, and then a couple more decimal places. Sorry, let's do 692. Okay, a couple more decimal places. This isn't quite an exact number. This one is. Leave it as a fraction. Okay, you don't need to go any farther than that. Leave it as a fraction. This one's going to be a lot more difficult also to check our work. So you don't have to worry too much about checking the work there, but leave it as a fraction if that's what we get. If you want to put a decimal in there and then try to solve, you'll get something pretty close to the answer. You'll get something pretty close to the answer, but it definitely will not be exact. All right, next one here. We have 3 over x minus 4 is equal to 11. Now this one, a little bit different. We have that x in the denominator. Get rid of the denominator, we need to multiply every side by x. So we're going to do dot x, okay? Because if we do x, then we don't know what exactly we're talking about so much. Okay, so we're going to do dot x, every single one. These ones here are going to cancel out, right? X divided by x is 1. So that's going to cancel out. That's going to, it's going to disappear. And we're going to be left with just 3, okay? So when we multiply by the exact denominator, we're going to be left with the exact numerator. 4 times x is 4x, and that's going to be equal to 11 times x, which is 11x. And now all of a sudden, we have 2 more. Okay, we have 2 variables instead of just 1. So now we have to bring our variables onto the same side. So we're going to add 4x to this, and we're going to add 4x to this side. Now again, when we add, we just do it to the same side because we're just adding terms. When we multiply, we have to do it to every single term because, well, whatever we do to one side, we have to do the other, and whatever we do to one term when multiplying, we have to do to all the other terms. 3 is going to be here all by itself. This is going to be 15x. We now divide both sides by 15, okay, to get rid of the 15. And I'm going to use a different color here. So divide this by 15. Divide this by 15. Oh, a little bit of lag there with the Kami drawing. And 3 over 15 is a fraction. Okay, we could divide it. 3 divided by 15 is in fact 0.2. Yep, 0.2. But we could also just leave it as a fraction. 1 over 5 is equal to x. Okay, which is also equal to 0.2. That is an okay one because that's an exact number. So we can leave it as okay. But if we don't, we can also just leave it as a fraction because that's also an exact number as well. Okay, a fraction is an exact number as well. Last one. Okay, we have 2 denominators, but both of them are x. So in other words, we're just going to multiply everything by x again. So times x times x, and times x. Okay, these ones cancel out, these ones cancel out, and so we're going to be left with just constants there, but we are also going to be left with some x values in what was constants, because now we are multiplying by x. So we're going to get 2x plus 3 is equal to 8 minus 3x. Minus 3x. All right, so once we're at this point here, now we want to move everything onto the same side. Again, like I've done kind of in the past, I'm gonna add 3x, that's supposed to be adding, and I'm going to subtract 3 from both sides. So I'm going to add 3x to both sides, and I'm going to subtract 3 from both sides. Okay, these are going to cancel out, these are going to cancel out, and what we're going to be left with here, we're going to write it out before we actually put everything together. Okay, we have 2x plus 3x is equal to 8 minus 3. Okay, so 2x plus 3x is 5x. 8 minus 3 is equal to 5. Now again, we do this because we want to get all of our x on one side and all of our constants on the other side. So at that point, we can then solve. We divide this by 5. We divide this by 5. This cancels out and becomes 1. This becomes 1 as well. And our final answer in this case is that on the left-hand side, we're going to be left with just x all by itself. And on the right-hand side, we're going to be left with 1. So x is equal to 1. All right, question 6 and 7. Question 6, you're going through and trying to solve for the variable. Question 7, I'm asking you to actually write out an equation that is going to have a fraction in there. It's going to have a denominator, and then solve for that one.